Okay, now here we're going to graph y equals the sine of 2x. Now before we do this, we want to know here, notice back to the sine of x. This is a sine function. So to graph sines, we refer to the sine graph. If this was cosine, we would refer to the cosine graph, like we did in the last video. This is sine. Notice the wavelength. The wavelength is the distance it takes for our graph to go up, down, and back up. Yeah, one full wavelength. So for here, for the sine graph, there's one full wavelength, goes up, down, and back up. This is one full wavelength. If I kind of cut and paste that over here, it's just going to get that. This graph is a whole bunch of these little wavelengths pieced together. Yeah, that's called a wavelength. Now, sine of x, when this is 2 pi, we have one full wavelength. Yeah, it's the same for cosine. We start here at the top to go down and back up to the top. That length is 2 pi. For sine and cosine, the wavelength is 2 pi. So we want to know, what is the wavelength for this? When is this equal to 2 pi? Well, we just solved that for x. When we divide both sides by 2, we find x is equal to pi. So this means this graph is going to go up, down, and up from 0 to pi. From 0 to here. So it's going to go up, down, and back up from 0 to pi. It's going to do it again. Up, down, and back up from 0 to 2 pi. So the number right here, that tells us how many wavelengths we have for our trig function. In this case, there's 2 wavelengths from 0 to pi. So it goes like this. Yeah, and that's our graph. That's it. If I were to put a 2 or a 3 in front of this, that would just stretch it out by, if this was 3, this would go up to 3 and down to -3. Yeah, and that's the idea. So that's how we graph when this part here, that's called the argument. When the argument is something other than an x, or an x plus or minus something else.